In order to assess the data set for tests, we are going to use this function, predict, that we've used previously also. So predict value, predict, you already know it. And I'm going to indicate that I want to do this with random forest that had the best performance. And I'm going to tell it that the data that I want to use to validate my model for that predicted value would be with the testing data. They've already been normalized, and it's going to show me the predicted values with that model. So since in this database I also have the original data, I can also compare them. If I want to generate my indicators for the quality of the model, for that prediction, I have to use this function called post resample. With this one, I have to write down the predicted values and the original values. They should be normalized already. In testing norm, I have to say that I want it to take into account my response variable. So it tells me that I have a good performance in the model, 0.06 in RMSE, very close to the performance that I had with my training data. And I have a 0.92 in R squared. Actually, it's very high for being a prediction model. I can also assess the results by using a diagram like the one that I showed you in the slides, where I can use the predicted values in one axle. In this case, they're normalized. In the other axle, the original values. Testing norm, yield, and I'm going to indicate that I want the points in red so that it's similar to the graph in the presentation. And I'm also going to tell that I want to use those points in red, and they have to be filled in. Now you can see the graph. Remember that what we want to do in our situation is to have a straight line, that the values that are being predicted by the model should be the same original values. But since that usually never happens when we use this information with so much variability and all those different effects, we actually have a very approximate model. I can also put my straight line by using this function, appline, from 0 to 1, type 2, and we'll see it there, the dotted line. When the original value is high, it appears that there's an underestimation of the predicted value. So probably the model here has more risk of failing. And that's also interesting. It's interesting to see it in these types of graphics. And finally, we can also use these measures that allow us to do an interpretation of the models. And I believe that I forgot to tell you about an important parameter for random forest. When I want to evaluate the importance of this, I have to write it down in the argument here when I'm going to train the model. So I'm going to execute it once again. I'm going to use importance equal to t, and it's going to execute the whole model once again. So in order to avoid the execution from scratch, because I was missing this value here, I'm going to tell it that I just want to take into account one parameter, mtry. This is one of the things that take the longest. I think that the optimal mtry could be seen here. It was 20. Mtry equal to 20, and I'm going to execute this model once again. This importance is important whenever we want to generate that ranking of variables that contributed the most to explain the response variable. So I'm going to leave it in the original script organized there. So I had to train my model once again because it is. Now what's going to happen is that it's not going to try these possible parameters, but it's going to use a unique model with the mtry equal to 20. And now we can do our exercise of the importance of the variables. So let's give it a little time. This is the random forest model. We have to be patient. Now it finished, and let's go and review. And effectively, you can see that an RMSE of 0.08, an R squared of 0.8. So what I'm going to do now is to generate the importance of the variables. And for this, I can save in this object. The function is also called the same way, var_imp, and it receives the model that I just trained. Model RF. I can do a plot on this right away. That's going to look very nice to try and finish these variables. And these are the most important variables. If the harvest cycle belonged to the Cusal location, Nariño. Also, the internal drain was important in the parcels, and also the slope. So I have a way to find out the importance of the variables in my model. This applies for random forest with other models. To obtain this importance, you have to probably explore other functions or to upload some other libraries, but random forest has this flexibility. It also allows to assess the partial dependencies. So I'm going to use it here. It's called partial plot from the random forest package. And I'm going to indicate the model RF. And I'm going to tell it that I'm going to keep the final model. And I also have to tell it what's the matrix that I'm going to use to train the data. So training norm. And once again, I want to tell it what's the variable that I would like to graph. Slope. So now we can see that the trend is that in the flatter the place, it does not coincide with the highest yields, but there's a 0.6 and 0.8 here. This is normal value, and we can denormalize it and do the same graph by doing some transformations. But apparently there's a peak where the slope is better for the crops, and after a certain value it flattens again. So these are the tools that are available for that model training, for the validation. And I think that we included most of the points that we saw in the presentation. And this applies for any database that you want to test. Now, from now on, you can use this same script for noting other databases and follow up the process.